I'm Dan Edmunds, and this is the 2024 Porsche Cayenne Turbo GT. It's a facelift from last year's model, but in the process they've added 20 more horsepower, taller wheels and tires, and a revised suspension, which we're going to look at in a minute after I take those big wheels and tires off. Well, the Cayenne Turbo GT's front suspension is something else, and it's dominated by this humongous carbon ceramic brake rotor and 10 piston fixed caliper. Just massive. This is longer than my size 13 shoe. Of course, we don't have an upper control arm. We have two links, so this is a multi-link suspension with a virtual upper pivot. We'll look and see what's at the bottom when we get in closer. Here's a closer look at the two upper links, and they're distinctly different ball joints. The actual pivot is a virtual point that exists in space if you extend this out and this out to a point where they intersect. And that allows the steering axis to be inside the humongous front wheel and tire assembly so that it's in a better position. Of course, we have an air spring here. Last year's Turbo GT had 3-chamber air springs. This has 2-chamber air springs, and the reason they're doing that is because of the adaptive dampers. They're now adjustable separately for compression and rebound. Last year they weren't. So here's a good look at the two lower links that approximate a lower wishbone, but are better than that because there's two distinct ball joints which allow for a virtual ball joint or virtual pivot point that's further outboard where it would be physically impossible to do otherwise. This air turner here makes it a little bit difficult to see things, but I think from this angle we can see this point, which is where the air spring, shock, and stabilizer bar, since they all come together a little further up, they all bolt right here to this link. And so we can look at the length of this link and where this position is relative to the overall length to determine the motion ratio. So here's our outer point. Here is the attachment point, inner pivots here. So it looks like it's pretty close to 0.8, about 80% of the way out. So that means that 1 inch of tire movement will compress all of the stuff that's bolted here 0.8 of an inch. The front bumper has this really cool, well, it's a wing really, underneath that allows air to flow over and under it. And when it goes over the outside bit here, it's directed along the bottom and it goes into this duct, which is brake cooling. So I've turned the wheel so you can see a little bit more, and that revealed quite a lot. So here is the steering arm. Now that I've steered the wheel full left lock, you can see that. These are turning vanes for cooling air that comes in through this ductwork and goes up against the brake rotor. So here is the stabilizer bar. The bushing is here, it loops around here, and that's the end of it. And then this link bolts through this bolt to the bottom of the damper and air spring assembly. So they all join up right here, so they'll all have a common motion ratio. Now this is an active stabilizer bar, but we're not going to see that. The mechanism is in there in the middle of the vehicle, so we're not going to see it. But what that does is allows a computer to either overdrive or underdrive the stabilizer bar to flatten cornering or to let the opposite sides articulate, depending on what's needed. So here we're seeing the rear link here, and this is its ball joint. And you can see that it curves around so that it doesn't hit the tire when it's turned, and mounts back here with a huge angular bushing. And that's because the rear link is the one that takes up any kind of reverse load that happens when you hit a pothole or something like that. it kind of turns that load into an inward pulse, and that big bushing helps dissipate it. Meanwhile, the forward link is pretty much square to the chassis, and that means that it's there to handle lateral cornering loads. But you need both, but they have slightly different responsibilities. Obviously, we've seen these massive rotors before, but you can see they're drilled, and the holes are actually between the vanes, not into them. And this backing plate is interesting because it stands proud of the rotor. And I can appreciate that, because one of the things you don't want to do when you're taking a wheel on or off is have the wheel hit the rotor and chip it, because that's an expensive mistake. This keeps that from happening. The back of the caliper shows that it is, a one-piece caliper with a permanent bridge here to give the caliper stiffness at all times. That means if you want to take the pads out, you've got to remove the caliper with these two bolts. Take it off altogether and put the pads in from the other side. An open window design is certainly convenient, but once you've got 10 pistons, you need a lot more stiffness across the middle so that the caliper doesn't just jack itself apart. So you need this fixed bridge. Anyhow, this is interesting. This is just a piece of steel that has been bolted to the caliper. It is a mass damper that helps quell a certain frequency of vibration they were trying to get rid of. So adding a bit of mass changes the natural frequency and basically can spoil the natural excitation that can happen if the frequencies align. So change the frequency and get rid of the sympathetic vibration. So this is the front tire off the Cayenne Turbo GT. This is a P0 Corsa from Pirelli. It is an 80 tread wear tire that isn't going to last very long. It's a 285/40 ZR22, which is 5 points taller than last year's model. So in off-road terms, this is a 31-inch tire. And let's see how much it weighs on his forged rims. 64 pounds. That's it for the front suspension of the 2024 Porsche Cayenne Turbo GT. I'm going to put this wheel and tire back on and see what's going on at the back. So here we are at the rear suspension of the Cayenne Turbo GT. And again, we have another carbon ceramic brake, this time with a 4-piston fixed caliper. We're going to look for all the links here. It's definitely a multi-link. You can see 2 of them here. You can see the damper is separate from the air spring back here, and then there's a lot you can't see until I move closer. This is the front end, and you can see here's the lower forward link, and this is the upper forward link, and this right here is the stabilizer bar mounting point. It mounts right here to this bushing, and you can make out the link goes down here. It actually connects to the bar right here, and there's the bushing, and then in the middle, again, where we can't see, there is an active coupling in the middle that can either overdrive or underdrive the bar depending on what is necessary. And it works depending on whether you're in off-road mode or Sport Plus mode or driving straight or cornering. All those things factor into it. So this shows everything that's going on behind the axle at the rear suspension. So we've got the toe link, which is attached to an actuator in there that gives this rear steering. This is the upper rear link, and this is the lower rear link. Now it's pretty big and fat, but it only attaches at one end at either end, so I call it a link. An arm has 2 pivot points at one end and 1 at the other. This isn't like that. This requires a forward link to help stabilize things in the fore-aft direction. It can't do it on its own, hence it's a link. So anyway, you can see you can adjust camber with this cam, and you can adjust static toe here. You still have to adjust the static toe. You got to center it, and then the steering will take over from there. The spring sits right here in the middle, so we're going to give it a 50% motion ratio from this point to the point where it attaches to the knuckle. This is the shock absorber's mounting point, and we're a little forward, so it's a little skewed. It's 80%. It might be a little better than 80%. I wouldn't go so far as to say 85, but somewhere in that range. This is one of the adjustment valves. The other one's kind of hidden just above it. My finger's touching it right there. So they're right next to each other. And of course, our aluminum knuckle that everything bolts to. Yeah, and then of course, this is a little aero cover that helps to flow the air over the rear suspension smoothly. This is the view from the front. Of course, there's a lot of hoses and things like that in the way, but the main thing to look at is this is the forward link. This is the stabilizer bar here, and that's the bushing. This is the drop link for the stabilizer bar, and this is the upper link, and the stabilizer bar mounts here, which looks to be maybe 2/3 of the way out. So the motion ratio for the stabilizer bar is probably about 67 to 70%. 70 if I'm being kind. And then, I don't know if you can see this, but this is a suspension position measurement strut, and there's a little electronic device here. There's one at the front, and of course they monitor the suspension at all times and feed into the computer that adjusts the adaptive damping and everything else. A bit earlier I said we couldn't see the actuator that adjusts the stabilizer bar. Well, that's true in the front, but here in the back, that's it right there. The stabilizer bar, one end goes in, and on the other end, the other half comes out. And so in there, the magic happens. Of course, the upper shock mount bolts to the chassis right here. Real easy to see. And we haven't seen a bump stop yet, but it's right in here. I can feel it. This boot is covering it, but the bump stop is at the top end of travel, like they usually are. So here's our adjustable shock that has adaptive damping, but this year, as in the front, they have separate valves for rebound and compression. I'm not sure which one is which, but I had a 50-50 chance of being right there. So the rear caliper is a Brembo, and I know that because, well, it's stamped right down here, just out of the frame. You'll have to take my word for it. But this also have mass dampers on it to defeat brake squeal, but this is actually right on the pads. These little weights here are riveted to the ears of the pad to keep the pads from squealing. So at least we know here what structure they're trying to quiet down. It's the pads themselves. Of course, this is a little wear indicator, and of course another fixed bridge here. So changing pads is a matter of taking off 2 bolts like we saw in the front. So they call these 2-piece rotors because you have the rotor here and the hat, aluminum, carbon, ceramic. Of course, you had to have 2 pieces because of that, but of course there's 10 bolts. So, and the bolts look like they are comprised of 1, 2, 3, maybe a 4th piece. So maybe they're 42-piece rotors. And of course, Porsche likes to use bolts instead of studs. And these little ears help hold the wheel in place, and then you can clock it until the bolts line up. This actually does save weight because a stud and a nut weighs more than a bolt and a threaded hole. It's not a lot, but it's something. Here's the rear wheel and tire assembly. It's a 315/35 ZR22. Last year, 315 and 22 were the same, but it was a 30. So the extra 5 points of aspect ratio make this about 1 inch taller and add more air volume that allows a lower tire pressure to be run. Anyway, how much does this weigh? 67.4 pounds. Not much more than the 64 pounds we saw up front. Well, that's it for this close-up look at the suspension of the Cayenne Turbo GT. I'm going to put this tire back on and think about possibly, maybe taking it in the back and seeing if it will go up my ramp. That's a big if, because this thing's pretty low and that front air dam isn't going to clear. But it does have an off-road mode, and I might as well see if that gives me enough clearance. Well, here we are. My ramp, it's pretty serrated, so you really don't want to touch bodywork against that. But maybe there's more clearance than I thought. I still don't think it's going to fit, but there's only one way to find out. Well, count me surprised, because there's clearance here and there's clearance here. Not a lot, but I think I have to try to go up. And if this doesn't work, there is a higher mode. I don't like using those because they end up creating a lower score because the springs are stiffer. That's how it raises the vehicle. So I prefer to try to do it in this low mode, because that's going to be the best score if I can drive up without this auguring into the ramp with disastrous results. Ow. I think I heard something I didn't want to hear. That's touching just a little bit. Too much to continue, so that's still solid. So the score for this car is higher than this, except this is touching. And hopefully we can get it down without tearing it up by backing it up. It should be okay. So the rear wheel back here is nowhere close to lifting off the ground, even while this is touching the ramp. I'm going to measure it anyway, but it's not going to be a real number. It's going to be a greater than this number, but of course that's debatable, because if you can't go up the ramp, then you can't get a score. So I'm just doing it to make some kind of point. All right, that's 13 5/8 of an inch of lift. Divide it by the sine of 20, and that's 39.8 inches of drive up the ramp to this point. Divide that by the 114-inch wheelbase and multiply by 1,000. And you get 349. But it's really more than that, or it's zero, depending on how you want to look at it. Anyway, the disconnectable stabilizer bars probably have something to do with that, because right now I'm sure they're decoupled to allow articulation. But if I didn't have this little piece on here, I could drive further up the ramp and get a better score. But I'm not going to take tin snips to a $200,000 vehicle that isn't mine.